Good morning, students. So in our previous classes we have seen that one cannot measure the the single electrode potential, and to do that we make use of standard hydrogen electrode, which we standard hydrogen electrode which we call it as She, and whose potential is arbitrarily taken as 0. So let's say, for example, uh, we need to determine the electrode potential of, say, copper electrode. So copper rod dipped in a copper sulfate solution. So what we do is we combine it with She, and then we measure the E of EMF of the cell. So we are let's say that this is E of copper minus E of She, and since E of She is 0, then what you measure is the EMF of the cell that you measure is actually the reduction potential of the copper electrode. So what is an electrochemical series? So electrochemical series are nothing but an arrangement of these values in a particular order. So electrochemical series or also referred as activity series is an arrangement of electrodes, that is metals or non-metals, that is metals or non-metals in contact with their ions arranged on the basis in the increasing values of the standard reduction potentials so that's what you call it as an electrochemical series. So below you can see the electrode reduction potential of few metals and non-metals arranged in increasing order. So lithium, which is having a lowest value, that is minus 3.05, is placed first, and fluorine, which is having the highest reduction potential, is placed at the bottom, and hydrogen, which has a reduction potential of 0, which we considered as the reference electrode, is placed somewhere in between. So the series runs from here to up to here. So it continues here because for viewing purpose I've just clubbed them into two tables, but they are actually, the copper comes below hydrogen and so on. And what you observe here is the following. So what does a negative value indicate to you? So what does the negative value here indicates, and what does a positive value indicates? So what does a positive value? So here this is highly negative, and whereas fluorine has a highest positive value. So what does that convey? So what this tells you is that a positive value for fluorine suggests that fluorine has greater tendency to go from F to F minus. That means fluorine has greater tendency to accept an electron. On the contrary, when you observe here, lithium plus E minus, lithium ion plus E minus gives lithium. That means lithium does not have that tendency to accept electrons. Rather, so that tendency is negative. That means it is not a very pleasing reaction for lithium to lose an electron and form lithium atom. Rather, it's easier for it to do the reverse. That is, it is easier for lithium to lose an electron and form lithium plus. So what I mean is that it is easier for lithium to lose an electron and form lithium plus. And this is kind of justifiable because lithium is a electropositive metal. So they have the tendency to lose electrons and form lithium plus to form salts. So this is kind of understandable. So what it means is that fluorine can accept electrons. So what it means is that fluorine, sorry, so fluorine can accept electron from the environment, let's say from another source or something, from source, and it is quite happy to form F minus. So we know that whenever a substance accepts electrons from another species, that means it can act as a good oxidizing agent. So we know that fluorine is one of the best oxidizing agent that is known. On the other hand, lithium, which has a tendency to donate electrons. So lithium has a tendency to donate electrons. So lithium has a tendency to donate electrons and form lithium plus. So that means it is donating its electron, and hence we say that lithium a great has the highest tendency to act as the reducing agent. So now we will look at some of the applications of electrochemical series. So the first application that we would see is the reactivity of metals. So reactivity of metals. Let's closely observe the electrochemical series. Now we see that some metals like uh, lithium, calcium, potassium are coming and at the top of the electrochemical series, whereas some metals like silver, gold are coming at the bottom of the electrochemical series. So based on that, we can say that metals which are at the top of the electrochemical series have greater tendency to form ions. So lithium, I said that, has greater tendency to perform the reverse reaction. So that means lithium has greater tendency to form lithium plus. And we all know that lithium is an alkali, or and it has greater tendency to form a monovalent cation, and it's one of the highly reactive metals. So this electrochemical series agrees well with what we already know from the experimental data. So first application of electrochemical series is one can one can judge which metal is reactive and which metal is not that reactive. So one can say that a metal which has greater negative value or smaller smaller positive value of standard reduction potential can readily lose electrons and form positive ions, or you can say cations. Such a metal is chemically active or is very reactive. So going by this judgment, we can say that lithium is more reactive than potassium, which is more reactive than say calcium and so on. And we also can see why silver and gold are noble metals, because they have a high positive value of, so high positive value of standard reduction potential. So from the table we can see that silver has a standard reduction potential of plus 0.799. So silver has a value of plus 0.799, while gold must be even positive. So gold has a value of plus 1.5. So gold has a value of plus 1.5. So that's the first application. We can also say that metals which have values about minus 2 volts or greater than minus 0.2 are highly electropositive metals. Highly electropositive metals. Highly electropositive metals. Whereas, sorry, this should be minus 2.0. So greater 2.0 volt or greater than 2.0 volts, we can call it as highly electropositive metals. Metals like lithium, potassium, sodium, calcium all come under this category. Whereas metals which are in the range 0.0 to minus 0, sorry, to minus 2.0 can be categorized as moderately electropositive metals. So metals like aluminum, zinc, iron come under this category. And any metals which have values less than 0.0 or which are placed below hydrogens, which are placed below hydrogen, they can be called as weakly electropositive metals. Weakly electropositive metals. So metals like copper, silver, gold, all come in under this category.